Let's apply what we've learned about P waves, compressional waves, S waves, shear waves, and surface waves to see if we can devise a seismic discriminant to tell us the difference between a bomb and an earthquake in terms of its seismic signature. In this figure from Seth Stein's book on seismology, we can see two seismic traces. The upper one is a bomb, 5.1, and the lower one is an earthquake, 4.8. Notice that the bomb has a very large P wave, as we expect. The earthquake, on the other hand, has a rather smaller P wave. But what we can see, in fact, is that the body wave magnitudes, recall body waves are the waves traveling inside the Earth, are very close to one another, 5.1 and 4.8. However, look at the surface waves. The nuclear test generated very small surface waves, and the earthquake generated larger surface waves. And we need to understand why that is, which we can do by looking at the following cartoon sequence. Here's our cartoon sequence of explosions versus earthquakes. Start with the surface of the Earth. Draw the location of our bomb. Draw the location of two faulted blocks, sliding giving the earthquake, one sliding down and the other sliding up. From the bomb, we have mainly compression, P waves generated. From the earthquake, we have both compression and shear, P and S. These hit the surface. The P wave from the bomb hits the surface, hardly any S generated. The P and S waves from the earthquake hit the surface, lots of reflected P, lots of reflected S, and they couple to give us those huge surface waves we saw earlier. Let's apply what we've just learned. We are going to devise a two-dimensional graph that will enable us to separate bombs from earthquakes. Look at Figure 1. On the vertical axis, you see the magnitude of the surface waves are plotted, and on the horizontal axis, the values of the body wave magnitudes are plotted. The graph has a line that separates bombs from earthquakes effectively. So you see the green dot above the line circled in orange. Since it's above the line, it has a higher surface wave magnitude than body wave magnitude, the line being a threshold discriminant that is computed. So that event, the green event, is definitely an earthquake. Now, let's look at the next slide. In that slide, you can see that the green dot is below the line. So we can assume that that is a bomb. So the relative body wave magnitude is larger. It's thresholded below the line. Let's apply that to the 2006 North Korean test data in the next slide. And you can see the red dot is below the line. We circle it in orange. So if we recorded that event, computed the body wave and surface wave magnitudes and plotted them, we would know that we have the signature of a nuclear test. To learn more about modeling and visualization and seismology, please consult the IRIS website.